right, let's start off with a joke. What did the acorn say to the mathematician? Gee, I'm a tree. Ha ha, get it? Geometry? All right. Anyways, let's talk linear and absolute value inequalities today. So this should be a bunch of review, but let's just recall when we're graphing a linear inequality, it's going to be similar to graphing a linear equation, except inequalities contain more solutions. So we are going to have a bounded shaded region. So our steps for graphing, make sure we are in slope-intercept form. Once in slope-intercept form, and don't forget if you divide or multiply by a negative, it flips the symbol. Once we have that, we're going to graph that boundary line. Connect the dots with a dashed line if we're less than or greater than, and connect with a solid line if we're less than or equal to or greater than or equal to. Then we always shade. That's the part of the inequality. There's always more solutions. So we can use a test point that's not on the boundary line and determine which side to shade. Okay, so let's do one together here. Y equals 3x plus 4. This is already in slope-intercept form. So my slope is 3. The y-intercept is 4. So we will plot that. Up at 4 and a slope of up 3 over 1 or down 3 over 1. Now we're going to connect the dots, but it's just a less than symbol. So it is going to be a dotted or dashed line. So I'm going to connect that with a dotted line. Use a straight edge, please, so that you can make sure you are graphing properly, and always continue it. Do not have tiny little lines. Okay? Now that we have our boundary, we need to shade. So I'm going to come up with a test point. Our test point, the easiest one to use, is 0, 0, as long as it's not on the boundary line. So in this case, 0, 0 is not on the boundary line, so we can use it. So I'm going to plug in x is 0 and y is 0 into the inequality. So 0 for y, 0 for x, and I simplify. 0 is less than 4. So is this a true or false statement? Is 0 less than 4? True. So my point was right here at 0, 0, which means that is part of the solution since it's true. So I am going to shade everything to the right of this boundary line. And again, don't be shy with how much you are shading. Okay? What that means is possible solutions, if you're ever asked, right? Possible solutions is anything in that shaded region. So for example, the ordered pair 2, 3, that's in there. The ordered pair 0, negative 5, that's in there. Okay? Etc. Lots and lots of possibilities. Okay, you try number 2. Make sure to put that in slope-intercept form first. How about number 3? Don't be confused that this is not in the form of y equals mx plus b. Remember, when there's just an x, that's going to be a vertical line. Okay, so we're going to go to where x is negative 5. Here we are. We're going to plot that, and we're going to have a vertical line. What we need to identify is it going to be dotted or solid? In this case, it's going to be dotted because there's no equals to. So I have my x value of negative 5. I connect that with a dotted line, and there's my boundary line. Don't forget about our shading. You can use a test point, or this is just saying all x values less than negative 5. So which x values are less than negative 5? Negative 6, negative 7, negative 8 are. So I'm going to shade everything to the left of my boundary line. Again, if you're asked to find a solution, just pick any points in that shaded region. No points on this line would be a solution because it's dotted. If it was solid, you could pick points from that line. All right, let's talk now graphing absolute value inequalities. We're going to graph these just like we did with graphing absolute value equations, but we're going to check for a dotted or solid line, and then, of course, we will have shading. So if we do the first one, Recall here, f of x is just the same thing as a y, right? They're always interchangeable. So let's think about what's happening. Usually our parent graph is at the origin, but we are moving to the right 2 and up 1. If I wanted to find that vertex, right, we set what's inside equal to 0 and solve. X minus 2 to 0 would give me a positive 2. And then on the outside is 1. So my vertex is 2, 1, and we can see that by the shift of right 2 and up 1. There are no other transformations, so that means the slopes are going up 1 over 1 and up 1 to the left 1. Now let's talk. How should I connect these dots? Should they be connected with dotted lines or solid? And in this case, because we're equal to, greater than or equal to, we are going to connect with a nice solid line. And again, use a straight edge to connect those dots. And make sure it extends. Don't just have a tiny V. Because now we need to shade. So to shade, you have two options. You can think about what this is saying, or we can use our test point. So I'm going to use a test point this time of 0, 0 again, because it's not on the line. Okay, so if I plug in 0, 0 for y, and 0 for x, this would be saying is 0 greater than or equal to, the absolute value of negative 2 is positive 2. So is 0 greater than or equal to 3? False. So we do not want to shade where 0, 0 is. So what that means is we want to shade on the other side, which is everything inside this V. You can also think about that because it's saying greater than or equal to, which means to shade above the V. And there you have it. You try number 5. Be sure to first get this so that y is alone. Then use your transformations to plot and use a test point to shade. Let's do 6 and 7. So number 6, don't get confused with this one either. Just make sure to get y alone. So to get y alone, we need to multiply by negative 3, the reciprocal, right? So this now gives me y is less than. I multiplied by a negative, so I must flip the symbol. Y is less than the negative 3 times the absolute value of x. In this case here, we're going to determine what that vertex is, right? Our vertex, our transformations, nothing is added to the inside, and there's nothing on the outside. So my vertex is just going to be 0, 0. However, we have a vertical stretch of negative 3. So it's a stretch of 3 and a flip over the x-axis because of the negative. So instead of opening up as a V, going up 1 over 1, I'm going to open down and I'm going to go down 3 over 1 because of that stretch. And again, down 3 over 1. Okay, I'm going to connect it with a dashed dotted line because we are not equal to, we're just less than. Excuse me. Excuse me again. So there's my boundary curve, V. And so now we need to shade. This time around, we cannot pick the test point of 0, 0 because it is on the curve. So I'm going to pick something like above it. Let's say 0, 2. And I'm going to plug that in. You can plug it into the very original, or you can plug it into once we have solved it. It's your choice. I'll just plug it into the original. So this would be saying, is negative 2/3 greater than 0? No, a negative is always smaller, so that's false. So my test point was here at 0, 2. It's not part of the solution, so that means I'm going to shade everything underneath the V. And again, that makes sense because it's saying all y function values less than or equal to, so we're underneath. Okay, and the last problem is absolute value of y plus 2 is greater than 5. Notice in this one, we do not have any x and y. We just have a y. So I'm going to put this, just so that my y part is alone, absolute value of y is greater than or equal to 3. Well, what do we do here? Well, when it's just a y, remember, just a y is a horizontal line. Okay, so we're going to have a horizontal line, but in this case, we're going to have horizontal lines, plural. The reason for that is, remember, back when we were doing absolute values with one variable, we have to set two cases. So once I have the absolute value of y alone, we're going to have two cases. Y is greater than or equal to 3, and y is less than or equal to -3. So we're going to plot both of these. So when we do that, y is greater than or equal to 3. We go to my y value of 3, and it's a horizontal line that's going to be solid because we're greater than or equal to. But then we need to shade. So we plot and shade that first piece. When I do that, it's saying all y values greater than. So that would mean to shade above. Now we're going to plot the second one and shade. So I would go to -3 and a solid line through -3. But I'm going to shade values less than -3. So here is the shading for that one. Remember, this is still one function. I want to use the exact same colors when plotting this, and a solution can be anything in either shaded region.